Hello everyone. Today I am going to show you the T flip-flop Verilog code and the test bench code. Let me open the T flip-flop Verilog code. As the name says, T stands for toggle. So whenever there is a clock, the output toggles. If T is equal to 1, the output toggles. So let us consider the inputs and the outputs for the T flip-flop. The inputs and outputs are included in the module. So T and clock are the inputs, Q and QB are the outputs. So initialize with the inputs T clock and the outputs Q QB respectively, and declare the outputs Q QB as registers, as we need to store the data. Let us consider with the positive edge of the clock. So consider always at the positive edge of the clock. Begin when there is a case. If this T is equal to 0, then Q follows the same inverted one, and if it is 1, it follows Q. So end the case. By default it will be the Q bar will be the negation of Q, and close the module, that is end and end module. This is about the Verilog programming. And coming to the test bench programming, here the inputs are declared as registers and the outputs are declared as wires. So T and clock are declared as registers and the outputs Q and QB are declared as wires. And consider the instantaneous unit under test. So unit under test for T flip-flop is considered as .T, .clock, .Q and .QB. So initialize all the inputs for the monitor. T is equal to %B, then T is equal to %B with Q bar, again %B with the T and QB. If T is equal to 0, Q is equal to 0, end it. Otherwise always consider with the positive edge of the clock with a 10 nanoseconds delay. So with the 10 nanoseconds, T is equal to 1, with 20 it will be 0, again with 40 it will be 1. This is how the test bench module works. Now let us move on to the digital part of cadence. So here, to invoke the cadence, type CSH. After that type source CSHRC underscore test. Now it shows welcome to cadence tool suite, and then type NC launch. Done. So now your NC launch window of cadence is opened. Under programs of Verilog, in the same folder I have created T flip-flop and the test bench file. So before that, whatever is there in the work library, just delete all the files. So I am deleting the previous files so that it will be easy for you to identify the correct programming which you are executing. So now the work library is empty. Just select T flip-flop and launch the Verilog compiler, and also for test bench launch the Verilog compiler. Now both will come under this work library. So we can observe T flip-flop and T flip-flop test bench. So previously I emptied the work library, right? So now under work library, select the Verilog file and launch elaborator. Again similarly for test bench, launch elaborator. Now once the elaboration is done, these two files will come under snapshots. So this is Verilog code and this is test bench code file. Now select test bench code file and click on launch simulator with the current selection. Always we have to select the test bench file. So launch simulator. Now two windows will be opened. One is the console window and the other one is the design browser. Here just select it and send to waveform window. So now waveform window is opened, and here in the waveform window just give 400 to 500 nanoseconds, and here we get the output. Just observe the output and check the Q bar outputs. So this is how T flip-flop output has to be seen. Thank you for watching the video.